Welcome to this second tutorial in which we're going to explain which were the modifications that we have applied to the version 2.0 of this package, the AR Simple Core. The first modifications we have applied are related to shaders. We do not use the CPU functionalities to obtain the subtle filter or the Gaussian filter or even, as you can see here, the deletion of the image. We use a shader, a complete shader. And in order to do that, we have to obtain the pixels coordinates, as you can see here, and multiply it by the mask. So the mask is composed by 1, minus 1, 2, multiplied by the different pixel coordinates, and the same for the derivative in y. Once we have obtained that, we obtain the mean square root value of that multiplication of the mask, and finally we have the result of the stable transform saved into a new texture. So that is the new pipeline that you have to consider for this package. So if you go to the image get optimized, we have changed a little bit the things. We have a main thread that is going to be an enumerator, and inside the main thread what you have is, first of all, we get the pixels of the camera, as you can see here. Then we call the first shader in which we're going to obtain the subtle transform. Then what we do is apply the half transform using the CPU, which is going to be quite long. It's going to take some milliseconds, and then that result we are going to put it inside a Gaussian filter in order to eliminate or reduce the noise. After that, we apply a dilatation process to the half transform, and also we apply the threshold, as you can see here, threshold half. So once we have done that, we apply the segmentation using the CPU again, and finally we call the function of the AR core, which is going to calculate the pose of the element, in this case of the 3D model. So as you can see, this is the result. Now the speed of the calculations are much higher. Everything is much faster. As you can see here, everything occurs in real time. You can move it around, and if you add a model in your AR core, for example 3D mode, if you deactivate the cube, deactivate the axis, and add the 3D model, you will see how the model works properly and it doesn't lag as it did before in the previous version. So that's all regarding this second version. If you want to check how things are achieved step by step, you can go to the main camera, to the canvas, and you have the post-processing image and display matrices. So you can display everything we have done in the process in order to obtain that pose. So you have here the subtle filtering, here you have the half transform, here you have the deletion process, and finally you have here the labels. And you have it completely organized in order to make it simple for you to understand how it works. So the default functionality are with those deactivated. I repeat again, you have to go to canvas, post-processing, and you'll be able to obtain the different images. Now if you go to the marker tracking, you have also a new functionality, which is AR core activated or deactivated, which means that if you deactivate it, you will only follow the different points. As you can see here, the rounded markers here, the ones that are circle with no inner part, correspond to the detection of the marker using the marker tracking, and the points that have fill inside are the points that are obtained by using the AR core. So whenever the AR core is deactivated, you will see how it doesn't match. But when you activate the core again, you will see how they match. So that's how things are done. Another important feature that you have in the script is the debug time. So the debug time, what it does is it shows you the time that takes the script to check the different stages of the process. So in like summary, we have the Sobel transform that is going to take 18 milliseconds. Then we have the half transform that is going to take 51 milliseconds. The deletion time plus the labeling process that is going to take 37 milliseconds. So that's the total time we have for the process. And then if you want to play around with the different thresholds, you can check the results by enabling the post-processing image again, and then in the image tracker you can say, okay, what happens if I reduce the threshold of the Sobel filter? As you can see here, if you reduce that, the half transform is going to take much more time in order to process the information, as you can see here, and it's going to create more lagging, but nevertheless the results should be better. If you set the threshold Sobel to a very low value, what you can see is that the lines are lost and the half transform doesn't work properly. So again, you have to check this a bit experimentally in order to have a good result. Let's check the threshold for the half. The threshold for the half, what it does is we'll check these maximum points that are in the half transform, and we'll take the maximum points after a thresholding process. So if it's too low, you will see how the result is really strange, because you will have too many regions too, as you can see. And if it's too high, what you will have will be no regions. So again, the values that we have added into the program are the standard ones that will help you have a good result. And finally, the threshold corner is used, as well as the square corner, to detect the colors here. So are the thresholds that are used to say which are the different colors of the marker whenever we are checking the mean color between this point here and the line that goes to the center of the marker. So for example, if we determine this threshold as a really high value, what it means that we are saying that we do not consider that squares that have a high value of pixels difference are accepted or not. So this is more or less how it works, and the other variables are the same as the previous version, so I think they should be clear enough. And that's all regarding this package. I hope you enjoyed the video, and I hope you consider downloading it and contributing to our work.